Welcome to the world of machine learning where striking the right balance is crucial for success. So today we will understand the enigmatic concepts of overfitting, underfitting and the bias-variance trade-offs, uncovering the secrets behind this art of balancing these critical factors. So let's get started. What is overfitting? Overfitting is a problem that can occur when you're training a machine learning model. It's like trying to fit a curve to a set of data points, but the curve is so complex that it bends and twists in a way that don't accurately represent the underlying pattern. Imagine you have a set of data points that represent the height and the weight of people, and you want to create a simple equation that can accurately predict someone's height based on their weights. A good equation would have a smooth curve that passes through the majority of the data points. Overfitting happens when your model is so complex that it tries to overfit every single data point exactly, even if it means creating an extremely complicated curve that does not generalize well to a new data. For example, imagine a curve that zigzags up and down, creating a very intricate shape that perfectly fits the data point. Now, this curve might do a great job of predicting the height of the people in your dataset. But if you try to use it to predict someone's height who was in your original data, it would be a poor predictor, right? So to summarize this, we can say that overfitting curve is too complex and does not accurately represent the underlying relations between the height and weight. And to fix this, you would need to simplify the curve or use a more robust model that can better generalize to new data. Then comes the underfitting. Now this underfitting is a problem that can occur when you are training a machine learning model. It is like trying to fit a straight line to a set of data points, but the line is so simple that it does not capture the underlying pattern in the data. So to continue with the example from this overfitting one, imagine you have a large number of data points that represent the height and weight of people, and you want to create a simple equation that can accurately predict someone's height based on their weight. Now this good equation would have a smooth curve that passes through the majority of data points. Now when the underfitting happens, when your model is so simple that it cannot capture the complexity of the relation between the features and the target variable. For example, if you use a straight line to predict height based on the weight, you will find that it does not accurately represent the data. And the line might be a good fit for a new points, but it will completely miss many others. So in this example, the straight line is too simple and does not capture the relation between the height and weight. And to fix this, you would need to make a more complex model like a curve or the polynomial equation that can capture the underlying patterns in the data. So to summarize this, we can say underfitting occurs when the model is too simple to accurately represent the data, while overfitting occurs when the model is too complex and does not generalize well to new data. And finding the right balance between the two is crucial for building an effective machine learning model. Then comes this bias variance trade-offs. Now this bias variance trade-offs is a fundamental concept in machine learning that relates to how well a model can generalize to new data. So it's like finding a balance between being too simple or too complex. Now to understand this bias variance trade-off, let us continue with the height and weight example from this underfitting and overfitting one. So imagine you have a set of data points that represent the height and weight of people, and you want to create a model that can accurately predict someone's height based on their weight. Now the bias one. So first aspect of the bias variance trade-off is bias. So the model with high bias is overly simplistic and does not fit the data well. It might use a straight line to predict height based on the weight, which is a poor fit for the model. So in this case, the model has high variance because it is too simple and does not capture the complexity of the relation between the height and the weight. Then comes the variance. Now this second aspect of the bias variance is variance. So the model with high variance is too complex and try to fit the data too closely, leading to overfitting. This might use an extremely complex curve that zigzags up and down, perfectly fitting the data points but not accurately representing the underlying pattern. And the goal is to find a balance between the bias and the variance. So the good model will be low bias, low variance. Means it is simple enough to accurately capture the underlying pattern but complex enough to make accurate predictions on new data. And in practice, this balance is often achieved by selecting an appropriate model complexity. example using regularization techniques, and adjusting the model's hyperparameter. So the striking this right balance between the bias and variance is crucial for building a machine learning model that performs well on both training and unseen dataset. Thank you.